Alright, so today we are going to learn how to use and manipulate a formula. A formula is just to express a relationship. For example, I have an x, that's called a variable, a plus sign, that's an operator, y, that's a variable, equals, that's also a mathematical symbol, and then a number. This is in standard form for a linear equation, and normally I would say solve for y, because then you get it in slope-intercept form. However, when you're working with the formula, you could solve for any variable. So on all of these, they said solve for x. When you're doing your homework, it may not always be x. Sometimes they say solve for x, sometimes they say solve for y. We are not going to be looking for a specific solution because we have two variables. In order to solve something with two variables, I would need two equations. So all we're going to do is we're going to rewrite it, solving for x. So what that means, all that means is you want x equals. If something says, that means x equals. So the first one, x plus y equals 6, we want x by itself. This one's actually pretty simple. I have a plus y, so I minus y. Solve for x. X equals 6 minus y. X is the difference between 6 and... Most times we like to write the variable first. Okay. Usually how we'll write it, we'll put the variable then the number. Solve for x. If you left it as 6 minus y, that's technically still correct. It actually looks nicer in this way, but this is more standard form, variable then the number. Questions? Number 2, again, it says solve for x. So I'm trying to solve for this x. Well, I could divide them all by 4, but then I get fractions. It's better to add and subtract first. So both sides. These cancel. So like the whole thing cancels, right? And then I get 4x. 7y plus 2y is 9y. And then I'm trying to get x by itself, so divide by 4. And it's solved. So I get x equals 9/4 of y. And make sure that y is on top. Make sure it's in the numerator, not in the denominator. Those are pretty simple. And if you take the accuplacer almost always has a question or two over this. And when you get to chemistry, when you're working with all these formulas, you'll have to know this skill too. 3, 2b minus ax equals 6b. Well, there's my x. So I'm going to try to get it by itself. So I'm going to get rid of the plus 2b by minus 2b on both sides. These cancel. And then make sure you bring down the negative ax. That's a common mistake I see. And 6b minus 2b is 4b. And then we divide by negative a. These cancel. And now let's solve for x. X equals 4b divided by negative x. Now if you wanted, you could bring the negative sign up to the front of the fraction. That looks nicer. You could bring the negative sign up to the numerator. That looks nicer. But technically that's also good. Any questions so far? We good? Okay, those were the simpler literal equations. Now let's move to a little bit more complicated. Trying to solve for x. And again, when you're doing it, you may not always say x, so pay attention to what you're solving for. Solve for x, that means x equals. Well, I have 4x. I'm going to add 2y to both sides. And if you wanted to, we need a minus 1 from both sides. You could do it all this at the same time. Put a line here so you can see the different sides. So I'm going to add 2y, and I'm going to subtract 1. These cancel. These cancel. Left with 4x. 5y plus 2y is 7y. 3 minus 1 is 2. Now I'm going to divide everything by 4. And there we go. Now 5y plus 2 divided by 4, that is fine. Or you could write this as 5y over 4 plus 2 over 4, which is 1/2. Both are acceptable. When you do the IXL, I'm not sure which one the IXL will want, but either one would work for me on the test. This is 5y over 4 plus 2 over 4, and 2 over 4 reduces to 1/2. Because I stole some room and I don't want those two problems to mix. Here. Did I? 7y? Oh, you're right. Thank you. Here at the front, 5y plus 2y, that'd be 7y. This would be 7y. And this would be 7y. Good catch. Good catch. And you might do that kind of mistake on your test. And I can clearly see by showing your work, you understood what you were doing. Maybe you were just going too fast and you forgot to add it, right? So then maybe I don't take off the whole problem. So it's important to show your work. Number 5, I have A times C equals G. There's two ways you could solve this. You could divide both sides by A. That's an acceptable way. However, you end up with fractions. So I usually encourage to just go ahead and distribute AX plus AC equals G. Again, you could have divided both sides by A, but then you'll have a fraction. And if you like working with fractions, you'll still get the same answer. From there, I'm trying to solve for X. So let me subtract off my AC. These cancel. And I get AX. Now G and AC are not like terms, so I'm just going to put G minus AC. Still trying to solve for X. There's an A in front, that means A times X, and an undo multiplication. You divide this by A, and divide this by A, and divide this by A. You could just write it like that if you want. Technically, that is correct. If you wanted to break it up into two fractions, it'd be g over a minus, and then ac over a, the a's would cancel, so you'd be left with the c. Now I'm showing you multiple ways because when you take the accuplacer, they don't always have it one way. Yes? Ashad? Question? No? So if you want to leave it like this, right here, you can, or you can write it like this. Same thing. Multiple choice, you need to know both ways. Number 6. Trying to solve for my x. I have x minus h divided by k is 7. What do you think we're going to do first? Times by k. And I get x minus h is 7k. Good. Now what? What do you think? Add h. Those go away. And I get x is 7k plus h. That one was actually easier than it looked. Number 7. Trying to solve for x. Now when you're solving these, if there's more than one x, like there's an x here and an x here, you do either one, or there's also another way to do it by factoring. But we only have one x, so that's good. What I'm going to do is I'm just going to go ahead and say, okay, this is negative 2j. What am I going to add to both sides to get rid of a negative 2j? Plus 2j. My ex I'm going to leave alone, but I have a negative 9 I could plus 9 on both sides. These cancel, and these cancel, right? So I'm left with an x, ex. 3m was not changed. 7j and 2j makes 9j. And negative 2 plus 9 is 7. Now I have ex times x, so how do I undo that? Divide by e. Now you can write this as 3m over e plus 9j over e plus 7 over e, or you can order the whole thing. So this is correct, or you could do 3m over e plus 7 over e, all the same thing. Okay. So the key to manipulating a formula is to treat every term like they are different, and then whatever variable you're trying to get, whatever variable they tell you to solve for, you get by itself. Yeah. So a first example, temperature. There are two different types of ways to identify temperature. For example, if I go to my thermostat, it says it's 69 degrees F. The thermostat on the wall says it's 69 degrees F. We, in America, use Fahrenheit. Other parts of the world use Celsius. And most scientists measure everything in Celsius. So This is no different than me speaking in English and someone else speaking in Spanish. There is a translation. There is a way to talk to each other by translating word for word. What does it mean when you say, mi casa, or something like that, my house. So this is the formula to go from, if you know your Fahrenheit, and you plug it in, it'll tell you the Celsius. And then there's a formula, if you know your Celsius, to go to Fahrenheit. Okay? So let's say the Fahrenheit Celsius formula is this. That is a true statement. You could always use this formula. So if we wanted to find out 69 degrees, what is that in Celsius? Okay? So it helps us to go from the standard measurement of degree Fahrenheit to the metric measurement, which is degree C. So the thermostat on top of ESB Financial says it is 46 degrees Fahrenheit. That's cold. You guys like 46 degree weather? Sounds kind of nice right now. So what is that in Celsius? Well, our Celsius formula is 5 ninths. Take your Fahrenheit minus 32 degrees. And that's it. It's a very simple formula. So we know that F is 46. So I'm going to put 46 in here. 46 minus 32. What's that? And then 5 ninths of 14. What is 5 times 14 divided by 9? Anyone have a calculator? It's too early in the morning to do it in my head. What is it? 70? Five divided by 9 times 14. 7. So if I was around that, I'd probably just say Celsius of 8 degrees. Okay. Does that make sense? Yeah, this is bothering me. I would leave it. What's that? I mean, 7.78 versus 8. I mean, what really is the difference? Not like you're going to change your clothes based off, 0.12 of a, or actually that's only 0.0 of a degree. No, 0.22 of a degree. So does that make sense? Now there's a formula, the Freefall formula. And this formula would be like if I took my pen and I dropped it, it would tell me how age, the height in feet. So if I hold this and drop it, this formula would tell me that, okay? Now if I put pressure on the pen when I throw it down, then that changes the formula, but if I just free fall, then this is the formula. H is your height in feet, so you would set this equal to 0 if you wanted to know about when it hit the floor, okay? V is your velocity, feet per second. T is your time. So if you use this formula, if I know this is 5 feet in the air and I drop it, then I could measure the time and then find the velocity. So let's say, and by the way, the velocity on Earth I think is 32 feet per second. Harvey the Wonder Hamster is shot out of a cannon at 100 miles per hour. Did the hamster survive? You think? a hamster shot out of a cannon at 100 miles per hour, do you think the hamster's going to survive? Anyone that lover of hamsters? I'm sorry if you are. I didn't make this word problem. But yeah, he survived. Someone like Superman jumped up and saved the hamster, right? So how high in the air is he after just 4 seconds? This formula, I know that 4 seconds, and my t is in seconds, so we know that t equals 4. T equals 4. So I could plug in 4 here and 4 here. And that will tell me how high this fortunate hamster is. Okay, I'm asking about how high the hamster is. I don't know that. So I have my I need to find my h, I have my t, now we need to find velocity. Velocity was kind of like the speed. So we know that's my velocity. However, the formula says velocity is in feet per second. This is not feet per second. This is miles per hour. So let's go back to probably 9th grade science class and convert miles per hour to feet per second. So we'll start at 100 miles per 1 hour. And I won't list the abbreviations because that might be confusing. So we're trying to make it look like miles per hour. And if you've never learned this from science class, now is a good time. So this we're trying to get from hours to seconds. Anyone know how many minutes are in an hour? 60. So because hours up here, I'm going to put hours up here. Why? So they cancel. Have you guys done that in science class? And you said 1 hour is 60 minutes. I'm going to write out the whole word so it doesn't get as confusing. So I just went from hours to minutes. Does anyone know how many, because we're trying to get to seconds, right? Because this is feet per second. Anyone know how many seconds are in a minute? 60. Now, minutes are down here. I want those to cancel. So I'm going to put minutes up here. $60 minutes. I'm sorry, 1 minute is 60 seconds, right? I am now in seconds. I have gone from hours to seconds. So we are almost there. We have our over seconds. Now I need to go to feet, and I'm starting off with miles. Anyone know how many feet are in a mile? Anyone know how far something is that's a mile away? $12 feet? There's 12 inches in a foot. That's going down too far that we need. Maybe I should send you all outside and make you walk a mile and count your feet. Alright, see you guys. You guys can walk in a mile in 30 minutes. Alright, go ahead, go. No? Actually, this is a number you probably should memorize. It's been a while since I've used it. I hope I remember correctly. But there's 5,280 feet in 1 mile. So I'm trying to get rid of miles. So I'm going to put miles down here. So if those cancel, 1 mile is 5,280 feet. It's been a long time since I've used that conversion. How many feet are in a mile?
1 mile equals 5,280 feet.
I'm correct. Okay. So now I am in feet per second. So I need to type in my calculator 100 divided by 60 divided by 60 times 5,280. Again, that's 100 divided by 60 because it's in the denominator, divided by 60 because it's in the denominator, times 5,280. Or your science teacher probably has you multiply across. Same thing. Okay? You could type in times 1, divide by 1, but that doesn't change anything. 100 divided by 60 times 5,280. 146. No reason to carry over the 0.67.